Hello and welcome to another instalment in my Python for Beginners series. In this video we're going to be covering more logic, specifically the use of and, or and not. Okay, so we've already looked previously when we did selection at equivalent to, less than, greater than, less than or equal to, and greater than or equal to. And we've seen how we can do this as a Boolean and it outputs true or false depending on the result of the Boolean operation. 5 is less than 10, so that's going to print true, which it did. For those of you that have been watching all of this series, you'll know that I keep switching out which IDE and operating system I'm using. I'm back in PyCharm, which is my favourite of the IDEs. Last time I used PyCharm, I was using a Linux operating system. This time I'm using a Windows operating system, and you'll see it works essentially the same way. The way you load it from the menu in the computer is different, but other than that, once it's loaded, it is exactly the same. Right, so we've seen that one that's true. We've got this second example here. Again, this is what we saw during selection. 10 is not less than 10, so the statement is false. And we can see it's output false because it's done the Boolean operation, it's set it here, and then it prints the result. That's just a little bit of a recap on what we did in the selection tutorial. Now we're going to move on to the AND operator and the AND gate. An AND operator is what we use in code. An AND gate is a physical circuit. So when we are using the code, we are basically telling the computer to use this circuit. And the AND operator, or the AND gate, has two inputs. Call it A and B, 1 and 2, first, second. There are two inputs. And for the output to be true, both of these inputs has to be true, otherwise it's false. Now, remembering that binary can also be zeros and ones, we got false and false is false, false and true, false, 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 and if it's true and true, it will output true, and only when both of these statements or these inputs are true. So, we have the first one. So we start with A equals true, B equals false, A and B, A, B, and we can write it just like that. And if I print, so this is our variable, we're assigning the result of A and B to it. I'll set a breakpoint and then we'll step in. So we've set A to true, we've set B to false. Now we're going to, if A and B are both true, this will be true, otherwise it will be false. It is indeed false, and therefore it will print false. If I change both of these to false, I'll just run it because again, it will say false because we've got false and false doesn't make true. But if I make both of these true, step in again. So both true, do the check. A and B are both true, so we will then print true. Let's put that into something slightly more functional. I'm going to copy this code, Save me typing it. So we've got a string variable called month that's been assigned the value February. We have an integer variable that we've assigned 29 to. And then we're saying that a leap year is day of the month is when the day of the month is equivalent to 29 and the month is equivalent to February. So this breaks this down in a few ways. It do the bits inside the brackets first. So it will say month equals month is equivalent to February. If that statement, that will be replaced with true or false. Same here. Day of the month equivalent to 29. That statement will be equated as either true or false. And then because it's an AND operator, if this equates to true and this equates to true, it will set this value here to true, and therefore we will print that as true. So let's step in. We have set the month to February. The day of the year is 29. So what we can say is because this month variable is equivalent to February, that will be true. Day of month, which is this variable here, is equivalent to 29, so that will be true. So we've got true and true. So this is now equated to true, and then we'll print true. Let's break that down, because we can say is 29 equals day of month equivalent to 29, and is February equals month equivalent to February. Put double quotes there. Whoops. So now it's a 29 and is February. And don't forget that's the equivalent to doing it like this. Now it's telling me that I can reformat that because it doesn't need it. It would run, but it's perfect. Oh. Acceptable just to put it like that. And it's going to break it down in basically the same way. So we've set the month as February, we've set the day of the month is the 29th. The Boolean, switching languages. Okay, so we've got month and day of month. This first Boolean is now true because the day of the month is equivalent to 29. The next Boolean is also true because the month is equivalent to February, which means that we've got true and true. And I could change this value Doesn't matter what I change it to. If I run it again, we've now got true and false, which means that we've got true, false, and it's not going to like, well, it's going to like it, it'll work, but it's just going to print false. Now, there are problems with that logic because there are, even though we can say if it is the 29th and it's February, it's definitely a leap year, there are another 365 days in the year, so we couldn't reverse that logic and make that still work. Let's take a look at another example. In here, we're starting by defining a list of ages. And then we're going to loop through the list like we saw last time. And we're going to say if the age is greater than or equal to 5 and age is less than or equal to 16. So anyone that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 or 16 will be included. It will print school age. Otherwise, else, it'll print not school age. So we'll set a breakpoint and we'll drop in. I'll come to why this is underlined in a few minutes. So we're going to step in. We've created the list variable. We've assigned the integers to the list. In the first case, age is 2. It's not greater than 5, therefore this will be false. Therefore we'll come down here and not school age. Come to the second one, exactly the same choice. 50 is not less than or equal to 16, therefore that will be false. So we've got true and false, that's false. And we use the else. Keep going through, same one. This time for 80. 80 doesn't fall into that range. 12 will do, so we'll print school age. 9 is, so again print school age. 30 isn't, so not school age. 6 is, so that's school age. And we can see exactly how that's worked. So we've got that must equate to true and that must equate to true for it to do this code here. Now, we can simplify this code. Rewrite it. We don't have to have an AND operator there. We can just say this time that age is greater than or equal to 5, or 5 is less than or equal to age, and, although we don't need it written, age is less than or equal to 16. And this does exactly the same result. It is just a simplification of the code. Still defining exactly the same range. Okay, so let's have a look at the OR operator. Again, we have two inputs, input 1, input 2, and we have an output. This time, however, if either or both of these are true, the output is true. So if false and false will be false, false true will be true, true false true, and also true and true is true. So let's take a look at that in code. So we've got two Boolean variables, first set to true, second was set to false, then got a variable called A or B, and that's equivalent to A or B. and then we can print the result. So we'll step in, true and false. So we're looking for either A or B to be true, to show true. That, of course, is true, and then we print the result. Alternatively, if I changed both of these to be false, it will output false. If they're both true, it will be true because it's either or. Either or both, that is. Normally, you don't see it written quite like that. You would see it written more like this. So we've got, if it's cold, well, cold is true, it is cold, and there's rain. If it's raining or it's cold, take a coat. And otherwise, don't take a coat. So again, we'll step in, set the two values. We have a true and we have a false. So this should go into the if, which it does. Conversely, if I set that one to false and do that again, we've got false and false, so we don't take a coat. Now, we can also do the school age logic from before with an or statement. Okay, so this is the same list of school ages that we saw previously. We've got the same loop going through this whole list. And we're saying if age is less than 5 or age is greater than 16, they're not school age. So we've reversed the way we're doing it, but we're getting the same result. Because if this bit isn't true, it will come here. So let's step in and look at this one. So in our first loop, we've got age is 2 if age is less than 5 or age is greater than 16. So this side's going to be true and it's an or, so this should come into here because the result of this is true. Print. Second one. If age is less than 5 or age is greater than 16, well, we have age is 50. It's not less than 5, so that's false, but it is greater than 16, so that's true. Because it's an or, we have a false and a true, so it's going to equate to true overall. The next one, we've got 12. Okay, so age is not less than 5 because age is 12. Sorry, I misread it. Age is 80, my apologies. So age is 80 for that third one. It's not there, so it's false, but it is greater than 16, that's true. We have a false and a true, so it will equate to true overall. So we're not school age. The next one is 12. Age less than 5 is false, but age greater than 16 is also false, so we've got a false and a false, so this is going to equate to false overall. Because the overall equation is false, we come down to the else, and this time we print school age. For the next one, age is 9. Age is less than 5, so that's false. age is greater than 16, so that's false. So again, we've got false and false. So that will overall equate to false, and we'll go to the else. Coming to the next one, 30. So age is not less than 5, so that's false. Age is greater than 16, because 30 is greater than 16, so we've got false, true. The result, because it's or, false or true, so it overall equates to true, and we'll do that. 30, so again, we're going to have age is not less than 5, so that one will be false, but age is greater than 16, because 30 is greater than 16, so we've got false and true. Comes to the next one, 6. I skipped a click by mistake, but we can see what's happened. Age is 6, age less than or equal to 5 is false. Age greater than 16, that's also false. So false and false is false. This doesn't run, and we come down to this one here. Last one then, 10. Age is not less than 5, because 5 is not less than 10, but age is not greater than 16, because 10 is not greater than 16. So we have false, false. So overall, this equates to false, which means that it will skip that and go to the else. Okay, let's keep going. The next one then is the not operator. The not operator is a little bit different because it literally inverts a single input. So if the input is true, the output will be false. If the input is false, the output will be true. So we've got set variable a to true. Not a is equivalent to not a in logic, and then we're going to print it. And we'll step in. That's true. Not a is now false because it's equated this and assigned it, and then we're just going to print and it's false. If I change this to false to start with, remember it just inverts it, so we're going to see the opposite output. So let's step in. A is false, not a will be true, therefore we will print true. Right, so let's have a look at a more normal example, because I mean that explains what it is, but it's kind of pointless. So in this first bit of code, this isn't using the not operator, this is just so you can see how it switches. I've got a is equal to 10, b is equal to 10. If a is equivalent to b, so in this situation that's going to be true, it's going to print there, otherwise it'll print not equivalent. I'll step through and show those two first. So they're both, that equates to true, so we come into here, and if I change that to 9, run it again, it'll do the opposite. So now, if a is equivalent to b, well, 9 is not equivalent to 10, so we come to the else. Right, let's just put those back. I'm going to put a bracket around that, and I'm going to put a not operator in front of it. And watch what happens now. Because we've still got both of those, but we've got A equivalent to B will equate to true. Then we're going to apply the not operator to it, so that will become false. So now, even though they are, it's coming here. Now, clearly, that's giving us a really silly result. And if you were going to do this with a not operator, you would need to reverse the position of the print statements. And now that will again give us an expected output. So those two again are equivalent. So that's true. This is going to inverse it to be not. So this is expecting false. Because this is false, it's skipped and it comes down here. Let me just do that one more time for you. So those two equate to true. That inverts the true to false. Because this only comes in here if this is equivalent to true, it skips and comes down here. So if I change that to 9, so A equivalent to B, that's false. The not operator inverts it, so this whole bit equates to true, so it will come in here. Print A is not equivalent to B. Okay, so let's have another look at another example of using not. Oh, there's a mistake there. I need to fix that. I'll go back and fix that afterwards. Right. So we have rain is true, cold is false. And we're saying to start with, if it's raining and it's cold, take a coat. Else if rain and not cold, so if it's raining but it's not cold, and it's not cold, take an umbrella. Otherwise, in the else statement, if neither of these is true, forget about a coat or an umbrella. Okay, so let's step in and let's run that one. So we're setting rain to true, cold to false. So if it's rain, and it's an and statement, so we've got rain and cold, so that's going to be equate to false because true and false with an and statement is false. So the second check, if rain and not cold, so if it's raining and that's false, see how these nots can make it very readable, but you have to think quite carefully about the logic here. So that and statement said if that's true and that's false, actually, we're going to come in here because that all equates to true. Because cold is false, the not reverses it, so that becomes true. Then you've got true and true, it comes into here. If I change this to true here, it will come into this one. And if I change them to both false, and run it, not that one, not this one, because remember, these are both false, but this inverts here, so that's true, sorry, that's false, and An inverse of false is true, so we've got a false and a true, but it's an and statement. So we drop into there. Okay, so now we're going to have a look at something a little bit more complex. And this next one will take you a few times to get your head around. And I'm going to break this down. I'm also going to expand this across so we've got a full window to look at. Let's break this down. We have a bank balance. The bank balance should have 9 zeros after the 1, an American billion. 2, 3, 4, 5, 6, 7, 8, 9. It does. We are stating that the Old English billion is bigger because it was a million. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. The American billion has 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. We've set a nationality to British. We're deciding whether they're traditionalists. I want to set this one to true initially. And then we start looking at some Boolean. In fact, that should read, oops. So we then create this Boolean here. I'm going to just break these down a bit first, because this is quite a long statement. First part, we're saying bank account balance greater than Old English billion. But that should say greater than or equal to the Old English billion. And British and traditionalist. Okay, so we've got a few different bits to work out here because what we're saying is this bit or this bit. How do we start? Let's start with this one here. So Old English billionaire equals bool. And we're saying that the bank balance is greater than or equal to the Old English billion. Apparently I can't spell. Okay, that's fixed. So an Old English billionaire is true if the bank balance is greater than or equal to an Old English billion. That's the first bit we're going to work out. So I can now replace that bit with that. We have another bool here that says for the British bool to be true, the nationality has to be equivalent to British. So Old English billionaire and British and traditionalist. So that's one set of brackets. If that's true, or what's on the right hand side is true, then they're going to consider themselves to be a billionaire. Or, so let's break this second part down. Bank balance greater than or equivalent to the American billion. So let's take that out first. Copy that. So an American billionaire, they're an American billionaire if the bank balance is greater than or equivalent to the American billion. So I can now place that bit with that. However, we need to make sure under this definition that they're not British and traditionalist. So British traditionalist is equivalent to a bull. British and traditionalist. So I can put that there. I can now swap this out. Okay, so we can see that this is now a little bit easier to read. So if they're an Old English billionaire and the British and a traditionalist, it will come in here because we've got the or. Or if they've got more money than the American billion and they are not a British traditionalist, they will also call themselves a billionaire. So we don't need this second lot of brackets here anymore. And we could lose this one as well, actually, if we wanted to. And now we've got two sides. So we've got that or that. And we can do that again. So final British billionaire is a boolean of these. Spell again. So I can say that so what we've done is we started with what looked like quite a complicated piece of logic, and it was, but we've broken it down. in the end, we've got two statements. So if that is true or that is true, it will come here. If either of these are true, it will come into here. If they are both false, it will come into here. Let's just have a look at that. Let's run it. So there are set values, and we're saying that they are a traditionalist. So the first equal we check, are they British? British is true. So for an old English billionaire, they need to have a bank balance greater than or equivalent to an old English billion. That's false. An American billionaire is bank balance greater than or equivalent to the American billion. That one is true. So, are they a British traditionalist? If they are British, which we established here, and they are a traditionalist, which is here, that will be true, which it is. So, the final British billionaire comes down to, is this true? Which is not. So that would, if that was true and that was true, this would be true, but they're not both true. One is false, the other is true. So that's false. Well, to be a final American billionaire, we've got to be an American billionaire and not a British traditionalist. So British traditionalist is true. So the not for here, when that's reversed, that's going to be false. And this is an and statement, so we've got false and false. Which of course, false and, or false or false is false because they're both false. Not a billionaire. And you can build these up to make really complicated decisions. Because let's change that to false and say they're not a traditionalist. Okay, so first point, yes, they're British. They still don't have more money than the Old English billion, so that's false. They still have as much money as the American billion, so that's still true. But this time, British and traditionalist is going to be false because British is true, traditionalist is false. So false and, so true and false, because it's an and, these will equate to false overall. So when we come to this one, all three of those have got to be true. So they've got to be as much money as English billion and British, so that's going to be false. But this time, they've got to be an American billionaire, which is true, and the inverse of British traditionalist. Now, the British traditionalist is true. Sorry, no, it's not. It's false. I looked at the wrong line. British traditionalist is false. So that false is going to be inverted by the not to true. So we've got true, and the American billionaire is true. So this time it'll print that they consider themselves to be a billionaire. Change traditionalist to true and change this to, and anything other than English would work the same way. Step in again. This time the nationality is French, traditionalist is true, but British will now be false because the nationality had to be equivalent to British and it's not. So because we have this in here, that will change when we get to it. American billionaire status will be true, British traditionalist false because they're not British. So we've got false and true, it's an and statement, so the whole thing equates to false. Because they're not British, that will equate to false. So we've got, for the American billionaire, we've got true. They are an American standard billionaire. They have as much money as a billion in America. Or they're anywhere now, but they are not a British traditionalist. But because of the not, that's inverted. So that becomes true. So we have true and true, which makes it work. So they will think of themselves as a billionaire because they've got as much as an American billion and they're not British. So if I change that to British again, 9, 10, 11, 12, add another 3 zeros on, make sure they are traditionalist, which is true. One last time. So this time we've set an amount equivalent to the English billion. Nationality is British. They are a traditionalist. So, first one, we're equating the nationality. That's true. Old English billionaire, this time this one is true. It still does this, but it's not really relevant. British traditionalist, they're British and they're a traditionalist. True and true. So, final British billionaire will become true because they've got as much money as the Old English billion and the British and the traditionalist. It does this line, but it's actually not relevant because his final line says if they're a final British billionaire or a final, so if either of these are true, it will come into here. Okay, I hope that has made some sense. If you want to leave questions, please do so, and I'll answer them as soon as I can. Thank you. Bye.